here's an example of how to do a work energy bar chart. And this is a way of analyzing the energy in a system at two different points in time. So in this situation, we're looking at a Hot Wheels car at the top of a hill, and that's the initial state. And then also at the bottom of a hill, so this is a lot like the lab we did. So we're imagining that the final state is there at the bottom. And it's important to notice that they're saying that we should ignore the effect of friction and air resistance on the car. So that's pretty unrealistic, but if we say that those are basically ignorable or negligible, then we have no work done by those forces. So right away, we can say that there's no bar or zero work done in that category, which tells us that mechanical energy is going to be conserved because nothing is interfering here with our car Earth system. And then because it says that the car begins at rest, we can also cross off the kinetic energy column. It does have, you know, a high height here that it starts off at. So we know it does have, like I'm assuming that that's our reference level here, down here at 0. And so then up here, it does have a lot of gravitational potential. Now, I don't have any numbers, so I get to just choose how high to draw this bar. So let's just say draw it at 4 bars high. But there are no springs or stretchy things that are stretched out or compressed in this situation. So I'm going to say that there is 0 spring potential or elastic potential energy. And so now I have filled out the whole left side of this equation. And then for the final state, I'm going to start with crossing off things. So it's definitely moving. I know it has kinetic energy, but let's cross off things first. Gravitational potential, it's at 0. So I'm going to cross that off. Sorry, my pen stopped working. Oh, there it goes. And then my spring potential, I still have nothing stretchy here. So then in order for this equation to be true, then everything on the left side has to equal everything on the right. And so I have 4 plus 4 equals 4, basically. So everything on the left must equal everything on the right. And then I need to make my kinetic energy equal 4 bars worth as well. Okay, and I'm done. Now, let's look at the next one. This one is the same situation, except this says friction and air resistance have a significant effect on the car. That's much more realistic. So I still am going to have no kinetic energy to begin with because the car is at rest, and then no spring potential or elastic potential energy is involved here. But I still, let's say, have 4 bars worth of gravitational potential energy to begin with. But since friction and air resistance are interfering with the car on its way down, then those do negative work on the car and take away some of the energy that it could have had at the bottom. So I don't really know how much I should draw, but I know it's negative. So you can choose. Maybe I would do -1 bars worth of negative work. So, and then of course I still have 0 and 0 here. So if I have 4 plus -1 has to equal 3 on this side. So then I would draw 3 bars of kinetic energy that the car will have at the bottom of the hill. Okay.